So in this mini lecture, we're going to head in a different direction. We're going to go back and do difference of means. Then we're going to do ANOVA. And then we're going to do simple regression. And the idea here is to help you begin to bring together differences of means test, which is one of the three categories I discussed earlier, and simple regression, which is one of the methods of predictive modeling that I laid out in one of my earlier mini lectures. So you should recognize this data. This is right straight out of the book where Oris administered tests to a group of students at 10 o'clock, another group of students at 11 o'clock. He drew a sample from each of the classes and obtained this data. So I taught this to you originally as running a two-group difference of means test. So what we'll do with this data that I've highlighted here is we'll first run it as a two-group difference of means test. I'll then actually run it as ANOVA to show you the similarities and differences between those two outputs. But then we'll also work with that same data and do simple regression. And then you'll see how these three different tests, two-group difference of means, ANOVA, and simple regression, actually give you the same results. So normally we would be in this screen. So the first one that we do is we go to add-ins. We drag over to Megastat. And we drag down to hypothesis tests. And we're going to compare two independent groups. Okay? So we click on that. And for my group number 1, I'll say that's my 11 o'clock students. For group number 2, I'll say that's my 10 o'clock students. Notice I only highlight the rows that actually have numbers in them. So I wouldn't drag all the way down. I only drag down for my 10 o'clock students as far as I have data. And I'm going to ask for the 95% confidence interval. You'll see momentarily why I ask for that 95% confidence. I'm going to highlight no difference between the two groups. And I'll do my hypothesis here as not equal, partly because there's no reason for me to think that they're different, but also because when I run the ANOVA, by definition, if you'll remember, the alternative hypothesis for ANOVA is always a two-tail test. So we click on OK. And we get these results. You may have to dig through your memory a little bit, but the fact of the matter is you've seen the results on this screen before. Maybe I can make that just a little bit bigger. Okay. You've seen the results on this screen before if you dig back through your notes, and probably even a couple of mini lectures dealt with this. So now I'm going to go back to the same data. I'm still going to work with this data right here, but this time I'm going to run ANOVA. Remember, the difference between ANOVA and the two-group difference of means test is that with the two-group difference of means test, you can only work with two groups. With ANOVA, it can handle 3 or more groups, but ANOVA can actually work with 2 groups as well. So I'm already at my add-ins tab. I go over to Megastat, and I click on Megastat. This time I drag down to ANOVA, and this is going to be a one-factor ANOVA test. So I click on one-factor ANOVA. And for my input range, I just highlight. Now notice here, since it's one-factor ANOVA, I have to highlight the entire series, so we actually are highlighting some blank cells here, unlike we would do in the difference of means. And we just click on OK. Now let me see if I can pull both of these in together. So notice here that my descriptive statistics pretty much match my descriptive statistics up here. But more importantly, notice that the p-value in my difference of means test exactly matches my p-value in my ANOVA test. So the point here is whether we process these data through the two-group difference of means test or through one-factor ANOVA, we get exactly the same results. The advantage of the difference of means test over ANOVA, the biggest advantage is in the difference of means test, we can get the upper and lower bounds and our margin of error. Whereas in ANOVA, that's not available to us. Okay? And I guess I should also mention, because this will be relevant when we run this through simple regression, our observed difference is 5.7 points. And that is derived from 152.3 minus 146.6 is equal to 5.7 points. Since we got a small p-value, we reject the null hypothesis, and we conclude that the 10 o'clock students scored higher than the 11 o'clock students, and we would draw the same conclusion down here. Okay? Now, let's go back to the data, and if you'll recall, I've taught you up to this point in time that when we do correlation analysis and simple regression, or really correlation analysis and regression in general, that we should only work with quantitative variables. Well, I'm going to begin to sway you away from that, and I'm going to show you how we can work with this same data here. We can work with this same data here, but slightly restructure it. Notice here in this column we have all zeros and ones, and that's class. So I set up class, the 10 o'clock class, I categorize those as zeros, and the 11 o'clock class, I categorize all of those as ones. Okay. So now I'm going to run I'm going to run a simple regression model with score as my dependent variable and class as my independent variable. And at this point, I'll say just kind of take my word for it that the results that we get are going to be directly related to what we just observed with our two group difference of means and our ANOVA that we just inspected. So again, we're on our add-ins tab already, but we would click on add-ins. We go over to Megastat, and we drag down to correlation and regression. And then we drag down to regression analysis. Let me clear my screen out here. So the first thing that it asks for is our independent variable. Now in this instance, our independent variable, contrary to what I've told you in the past about the independent variable needed to be interval or ratio in scale, this time our independent variable is a two-level nominal variable, and that's our independent variable. And you'll see in the book, it's what they call a dummy variable, D-U-M-M-Y. Don't worry about what that means right now, but if you hear me use the term dummy variable, that just means it's a 0, 1, two-level nominal variable. And then for our dependent variable, that's score, which is this column here. Okay. And that's everything that we need to highlight for this. So we click on OK. Now, recall that our p-value when we ran the two group difference of means test was 0.017. Our p-value when we did ANOVA was 0.017. When we go down to the simple regression output, notice here 0.017, and here it is also 0.017. Okay. Notice that in our two group difference of means test, when I ask for the margin of error and the 95% confidence intervals, what you'll see is the lower and upper bounds for our 95% confidence interval in the difference of means test, our lower and upper bounds for the 95% confidence interval in our difference of means test, those values are exactly equal to our lower and upper bounds in our simple regression model. You'll notice that the point estimates of 152.3 and negative 5.7 correspond exactly to 152.3 and negative 5.7. So while we teach you in introductory statistics classes while we teach you that regression analysis is a predictive modeling technique that is reserved primarily for quantitative data, either interval or ratio in scale, the reality is you can actually do a two-group difference of means test. You can actually do the equivalent of a two-group difference of means test in ANOVA, okay? The benefit of doing this in simple regression as opposed to the two-group difference of means test is probably the fact that we have an R-squared number to look at, okay? Because I don't think you see anything up in simple regression. I don't think you see anything up in the difference of means test that would give you a numerical indicator of how strongly related the two variables are to one another, or how much they differ from one another, for that matter, okay? Whereas down here in the simple regression, we do get the R and the R-squared values, okay? So I'll give you a memo on this, and we'll talk about this in class additionally, but I think it's very important for you to begin to see the link between the two-group difference of means test, ANOVA, and simple regression, okay? And hopefully this memo has helped you start along that journey. Thanks.